in this program. So our speaker today is Dr. Vitaliy Zemlyak. Zemlyak is her name, and he is head of laboratory. It's called ICE Technologies. So he's doing experiments, which is I cannot say unusual, but different. What's me or Emilian doing for us, the computer is quite enough. But Vitaliy, he is doing a variety of things. So that is the very valuable for us in terms of validation of our models and to understand what's actually happening in reality. Yeah, so this seminar is recorded. So if you ask questions, you can ask anytime. And at the end, please ask questions. Just remember that it's recorded. Okay, please.
The coolings, the motions of the load along the ice sheet leads to the formations of systems of flexible gravity waves. If gravity wave in water examples flexible wave in ice plate, these combinations of waves will be called flexible gravity waves. The speed of moving load equal to the speed of flexible gravity waves propagations will be called critical. Today we are large number of works dedicated to the theoretical and experimental research on a load motion over I square at all. However, the problem of the flexible gravity waves generated by the motion of a solid body under ice cover has been studied in sufficient among the first theoretical papers of the subjects is a work by Hesse, who studied the plane steady state problem of the motion of a vortex wander over of broken ice. Ukatov and Zharkov and Kuzin and Pogorelov studying the steady motion of a point source of mass under a floating elastic plate, and with it the effect of the velocity of motions, the depth of the source and the thickness of the plate on its deflections. In Sturer works, the solutions of the linear steady problem of the flow of non-viscous liquid around a sphere under the ice cover, broken ice membrane, and also under the free surface is performed. Korotkine considers the nonlinear problem of non-stationary waves caused by the submerged ecliptic cylinder moving under the ice cover. The possibility of breaking natural ice natural ice covered by flexible gravity. Motion of model submarine vessels on the was shown in the work Kuzin et al. The research on the influence of thickness of the ice plate, the depth of the body, its dimensions, and the velocity of the amplitude of deflections of ice plate was carried out on the basis of the received theoretical dependence. So Pogorelov et al. At present, wide experience has been gained with the operations of nuclear submarines making long passage under ice in the north. However, emergency situations can arise when a submarine needs to surface from continuous ice cover. As a rule, surface of a submarine vessels is accomplished by reducing a steady flow on ice from below due to creations of positive buoyancies by draining the ballast tanks. This method of surfacing, however, has a number of drawbacks. These drawbacks can be eliminated by subject size cover to hydrodynamics loads with arrays needs the bottom surface of a moving submarine vessels. With the help of flexible gravity waves in the ice cover caused by submarine vessels, spectral of complete ice value can be achieved, which will allow submarine vessels emerging in thicker ice as concrete with the traditional method of surfacing. In 2012, on the basis of the constructed ice tank, the laboratory ice technology, Shalom Aleichem Primorsk State University, Abidjan, Russian Federation, was created. The laboratory conducts research on the destructions of ice by flexible gravity waves from the motions of submarine vessels and the investigations of the effect of various ice conditions of the parameters of flexible gravity waves. The main element of the tanks is a ball equipped with a rail with a towing carriage, which allows the model load to the pole. The tank is welded constructions and forces with ribs installed on the foundations and covered with a layer of insulations. The private ice on the inner surface of the sides of the tanks, heating elements fixed of the ocean wall surface. The ice tanks is equipment with systems for collecting and model ice melting. After the test, the broken ice pieces left in the ice tank are removed into special tanks, which is a metal container covered by a layer of insulations that has electric heating elements. The collections of broken ice pieces is performed which a towing carriage which has two compartments for loading the broken ice and removing it of the tank to melt. To move the compartments in vertical directions, the models of vertical cement and rail wheelways with a block tip, where the compartments are fixed are used. The collection of broken ice pieces is carried out using a towing carriage, which has special hills installed. Double bottom was modeled by using sections mounted on the movable models to set required water depth by use of computer control. Due to the lack of refrigerator machines, experimental studies were carried out only in the winter period, December and January. The model of the ice cover was made in the ice tank by freezing natural fresh water without any paint up to the seat thickness 3 mm in natural conditions. The rooms where the tanks is located was not heated for the entire winter period of the experiments. The experiments were carried out only at night time, when there is uniform size sheets is obtained in 2 holes at night. Except for the pitches of snow on the ice. Effects of shoals and winds from the outsides were minimized as the ice tank. Due to lower of insulation materials installed on the sides and under the bottom of the tanks and completions with constant temperature mode, the thickness of the ice on the walls on the tank and is the middle of the ice field did not exceed 1 mm. After carriage out of each model test, broken ice pieces were removed and the depth of the model was adjusted and when this ice sheet was fallen. To conduct the experiments, necessary equipment and messengers systems of register vibrations of model ice was prepared. By towing the model vessels with velocity and profiles as flexural gravity waves were determined. To record the vibrations of the model ice, we used infrared non-contact vertical traverse sensors. The profile of the waves generated by the moving model was recorded with the help of the program test viewer. The towing systems allowed carrying out models tested at velocities of up to 2.4 meter per second on the steady motion conditions. Steel cable with a diameter of 3 mm was used for towing the models. The strength of the cable provided tensors of models necessary to exploit change of dipping in the course of motions. What was determined experimentally by means of test starts on clear water before carrying out each series of experiments. Change in towing velocity of the model submarine vessels was recorded with the help of the servo driver. To carry out model experiment, 9 models of submarine vessels were made. 3 models represents the models of submarine which are all part of the Navy of the Russian Federation. All the project have various displacement, length, form of cross sections, and protruding ports. The over 6 very simple models of submarines in the form of bodies of rotation of teardrop shape and ellipsoid of rotation, preserving the main characteristic of the project's length, displacement, and the area of the midship sections. The value of protruding ports was tributing from the volume of manufacturer's models. Simulation scales equal was selected tank of the size of the ice tank with the length of the channel, providing access to the steady motion of the model submarine vessels. The width was sufficient to eliminate the influence of the waves reflected from the channel size of the principal wave systems. Modeling of the ice cover can be accepted by using various size models, and for each of them there are corresponding conditions of similarity. The usual modeling is performed with better satisfactions of conditions of similarity. When natural ice cover is used as model 1, the thickness of the modeling ice will be calculated when converted to natural one in accordance with the following relations. Determination of flexural strength of the model was experimental performed by testing beams, and from what purpose the model ice cover was prepared by building up ice of the required thickness 3 mm. The average value of the flexural strength for natural ice was the value of 0.7 megapascal. The thickness of the modeling ice cover after conversions of natural one was 2 meter. The coefficient alpha was used as a criterion for breaking model ice. That is equal to the maximum value of the tangent of the surface slope of the ice plate. The relations between failing of ice cover and the coefficient alpha was already empirically determined in Skozin's experiments work. It was stated that for the load motion over the ice cover as well as for motion of a submarine vessels, when the maximum value of the slope of the ice surface is greater than the value of 0.04. It leads to complete ice failure and cracks popping. We should note that as far as the value of the critical was obtained for the complete failure of freshwater ice. Its usage for assessment of the ice failure is not entirely correct. However, if we take in account wet ice strange and fracture, thickness of the ice is lower than wet of fresh water, the value of alpha for the ice would be a bit lower. In the laboratory experimental studies, there is very carried out on the influence of the shape of submarine vessels and various ice conditions, depth and topography on the bottom, the of hammock ice cover and free edge of ice on the parameters of the generated flexural gravity waves. When solving the problem of motions of submarine vessels near the ice surface, the hull of a submarine having a complex geometry is usually regulated by the body rotation of a simple form while preserving its main characteristic, elongations and displacement. In its turn, the presence of protruded parts as well as the form of the cross sections of the hull can have a significant influence on the parameter of flexural gravity waves generated by submarine vessels' motions. The given paper presents the experimental research of influence of a form of contours, the form of cross sections, and the presence of protrudent parts of the deflections and the length of flexural gravity waves. The results of the studies show that the use of simple submarine vessels models instead of submarine vessels models for real ship is not always expedient. The protruding ports do not significantly affect the parameters of generated flexural gravity waves, but the form of cross sections can influence the curvature of flexural gravity waves. We will note where for submarine vessels of other models in operations, such kind of experiments are also necessary. Character of the failure of the model as by flexural gravity during model submarine vessels number 3B, motion at critical velocity. The authors have experimentally determined what the effectiveness and failure pattern of ice cover caused by flexural gravity waves generated from the motion of submerged body near the bottom ice can greatly depend on the depth of the water area. In turn, the presence of ledge on the ice surface may affect on the wave propagations pattern. This paper present experimental study of influence of bottom contour of the deflections and the length of the flexural gravity waves. The experimental study of the influence of water depth of ice-breaking capacity of flexural gravity waves caused by the motion of a submarine vessel's model near the ice. The results of the studies show what water depth has a significant impact of the parameters of flexural gravity waves generated by the lower motion. Given that the destructions of the ice takes place of velocity much lower than in the deep water, the value of critical velocity also depends on the water depth. Practically entirely considered cases and intensive is ice pieces crashing and ice cover completed lost its carrying capacity. Experimental study of the impact of ledges of the bottom of the lens and deflections of flexible gravity waves generated by the motion of the immersed body. Analysis and comparisons of the data demonstrations of significant effect of simulated conditions of the parameters of the model of flexible gravity waves. Presence of the ledge gives this hydroshock and leads to a sharp increase of curvature of flexible gravity waves by comparisons with the continuous flat bottom. The minimum velocity of the lowered motions at which the destructions of ice occurred was significantly less than in the case of infinity depth of the bottom. Effect of wind and currents in the ice field can cause the compression process leading hummocks. The experimental study of the undeformed state of hummock ice cover during submarine vessels motions, freezing transverse strips of ice formed area of hummock ice. The dimensions of the ridges and their location relative to the rate of motion of submarine vessels are illustrated. The pilot study showed reductions of the variations of deflections of flexible gravity waves from a decrease in the depth of the water area, significant change of crest velocity of a lower for smooth conditions. Ice with a limited depth of the water area have not been established. The dependence of coefficient alpha from velocity of a moving fluids show that the intensive destructions is curtain will range of velocity under the study. The most intensive ice failure and ice pieces pushing occurred at near critical velocity. Ice cover complete loss is the carrying capacity when Newton's model velocity, the area of the fracture was abridged significantly allowed. The intensive of distractions at low velocity was higher at a velocity grid on the critical value, which is saturated with Higgs created of flexible gravity waves. The experimental study of the influence of an open longitudinal crack or ice fracture of various widths of the deflections results in ice cover during submarine vessels motions. Unfortunately, the results of the experiments have not yet been fully processed. Video fragment of the movement of the model of submarine vessels under the ice cover is
good.
Questions? Yes.
Is the ice clumped at the bottom?
На боках жесткое зачемление.
yes, yes.
In the last video, it looked like the ice is broken well after the body passed that place. So it looks like it's broken by waves.
Yeah.
By long waves.
By yeah.
Long
Yeah.
waves. And also that in this video, could you see that the
Can we show video again? Video slow.
before the motion we have a like a cutting of the ice
Ah.
at the center.
Yeah, that is the. So there are two plates. this open water between them. Mm.
Okay, I see.
And
So
also,
there's a crack in
also
the
you can see
Yeah.
certain angle.
Разводим.
This is the pattern of the waves. How thick was the ice?
Say
Millimeter. Millimeter.
millimeter. Say millimeter.
Natural ice 2 meter.
Yeah. Are there any experiments in the real ice with big submarines or no?
Not only experiment. Yeah.
Big
Not
submarines
yet.
very expensive.
Yeah.
Yeah.
I wonder which software did you use and did it needed constantly presence of operator there to check all the experiments, or it can be automatized somehow? Вы использовали какое программное обеспечение для того, чтобы проводить эксперименты? И необходимо ли было, чтобы постоянно там был оператор, и это можно было делать автоматически?
Да. Оператор должен быть постоянно. Ну, программное обеспечение, оно лицензионное, к датчикам идет. Датчики немецкие.
Не LabVIEW случайно? Нет.
А подождите, LabVIEW обработка была. Тест-вивер у нас и что-то я не помню.
Ну, как у вас система вся работала, сразу данные шли на компьютер, и это все же управлялось, как бы все механизмы, все движения из одной программы?
Нет, там комплекс программ, потому что на каждый сервопривод идет отдельный. Тут очень много двигателей, на самом деле, просто за каждый элемент установки отвечает двигатель.
Было бы интересно сделать систему автоматической. У нас не лед в Тель-Авивском университете, но у нас мы волны изучаем, и есть возможность сделать автоматическую систему приведения в движение и записи тоже. Было бы интересно.
Мы сейчас обновили комплекс полностью, удлинили чашу бассейна, сделали отдельно.
Wait.
I'm sorry, this is
It's very long question. Please say the same from beginning. Yeah.
Summary.
Summarize
Okay.
for all others.
So my question was about the software which is used for making the experiments and collecting the data. I wondered if it is LabVIEW or any different complexes of programs. So the answer was yes, there are different complexes of programs which is used to collect data, and as I understood now you have a new facility and it probably can be automatic. Because in our university, in Tel Aviv University, we don't have ice, of course, but we use similar wave tanks for exploring waves, and we have fully automated procedure which starts from moving mechanisms and then to measure all the waves to the calibration and data collection is all the same. So we only need once the assistance of operator in the beginning, and then I can just go in the morning and collect all the data and not be presented there during home night. Okay. I'm sorry, it's a long question,
I
but
don't reason to be there all
um,
night, I guess.
yeah, because it's freezing here to sit there.
Mm.
Can you fly drones?
Sorry?
Can you fly drones on top of the water of the ice?
Drone можно
Like plane.
Там маленькая.
It's the height
Okay.
of the room is small.
Yeah.
Yeah, but it looks like somebody over there. You see in the window. Is it you? No.
So
You are head of this tank, right?
Is it better to break the ice with submarines or hovercraft? That's one.
Yeah, it's better.
Ну, лучше.
Подводные лодки лучше разрушать или по поверхности?
От задач зависит. Ну, submarine.
Нет, если разрушить лед надо.
Если цель разрушить.
Если цель разрушить под водой или над водой.
Под водой.
Под
Water.
underwater it's easier.
Okay.
Moving underwater it's
Because in Canada they use hovercraft to break the ice.
Yeah,
Там нет
yeah,
энергозатрат, надо только разогнать.
yeah.
Okay.
He's saying it's from terms of energy, it's more efficient if something moving under the water. The energy is spent only on mainly on accelerating the body, and after that it moves on its own and
It can break thicker ice. Yeah.
Yeah.
But I think that there's a hovercraft that is cheaper than real submarine.
Yeah, but I think if the ice is too thick, hovercraft is not working.
No, but submarine also doesn't work. Yeah, I remember it's the NASA report 1995. It's about American submarines, and it's written that it's written there in the summary that we cannot use the submarines in Arctic because in the case of
If
emergency.
you get out, yeah.
In the case of emergency, there are no chance to, submarines are not well kind of developed. So, in case of emergency, they cannot go on the surface. And they can break ice, American submarines that time, not now, they can break ice about 1 meter only.
But I think Kozin said that it can break thicker ice.
Yeah. Yeah. So this is still under kind of investigation. Because they use the different things like that is a tower on the top. They can use as a hammer, right? But you can just break it. I remember from that report, 1995, that if the tower is broken after servicing, then you cannot operate the submarine anymore. Yeah. So that is the great. So that is another technique. There are no contact with ice, just something moving at certain speed, generating waves. And from physics, if you generate waves at the same speed as waves propagate from that place, then the energy is accumulated and the deflection of ice in this case is also accumulated and ice can be broken. So that is called resonance method of breaking ice. So it's more about technology because the laboratory is ice technology. So everybody knows
So
that it's
it's
possible.
salty ice, yeah? Or salty ice?
Could be not, it's fresh
water?
water.
Fresh water.
Yeah. Because there is, Vitaliy told me there is another problem. You can put salt in the tank, but then
It will
all your things will be corroded and die quickly. So it's not a good idea to use the salt. Or should be special. I don't know.
In Hydrolab in Germany.
In Hamburg.
They've done experiments. I talked with Agnieszka. And
Yeah.
They've done experiments, but only with salt water, like in Baltic Sea, not very salty, because they didn't want more because they break the instruments.
Yeah, but in the tank.
In the tank.
In the tank.
So it was 7 to the 1,000, which is like similar
Right.
with the
Yeah.
Baltic Sea, not like
No.
proper oceans.
Yeah.
So they didn't want to put more salt.
Yeah. So that is the very unfriendly ocean water.
How deep is 1 meter deep or?
What's the depth? 1
1
meter.
meter.
1 meter. 1 meter. And it's 4 meter wide, 3 meter
3
wide.
meter and 14, I think.
Yeah.
It's 2-dimensional, sort of. Okay.
Yeah.
It's still have 3-dimensional.
And that kind of that submarine moving model submarine is about 1 meter long. Yeah, 1 meter. And from 1 meter to 1.6. And this is a scale 1 to 100, right? So then this means the actual submarine is about from 100 to 200 meters. Is it so too big?
200 elastic.
200?
200 elastic. Резина.
No, submarine. Length of submarine. Is it up to 200 meters? What's the longest
Real
submarine?
submarine, then
Самая длинная
Это
подводная
тысяча
лодка. Сколько это? Настоящая.
Где-то около 170.
Okay. 160, the longest. 160, the football
It's
pitches.
100 pitch, 100.
Yeah,
So almost twice the football pitch.
almost twice football. Yeah. And so just multiplying by 100, right? And beam is from
Beam is lateral, yeah.
10 to 20.
So L is the length.
L is the length, B
So
is
it's
the beam.
160. Okay. Beam is the weight.
Width.
Yeah, yeah.
Beam. And D, okay, D is the weight.
The weight.
And I turn into the question from Anna. What actually you measured with Mechanica? Okay. Deflections.
Length длины,
Length of what?
flexible gravity waves,
Ah,
project.
And deflection.
Deflection. Deflection. Deflection. At how many points? Сколько точек? Сколько датчиков?
4 минимум. Ну, обычно там 6-7. 6, 7.
Okay, 6, 7 points to measure deflection.
And this breaking coefficient, so how is it calculated? Alpha.
Could you explain? Можно объяснить про альфа еще раз? That breaking coefficient. What's that? Alpha.
So W is
Actually, it's slope. Right?
it's slope. Okay, slope.
Yeah, the WM is maximum maximum deflection.
Amplitude.
And lambda is
And lambda is length,
Не амплитуда.
kind of length.
Именно project.
So it looks like the slope,
Okay.
and 2 pi due to something.
and alpha Heft is smaller than or bigger than something.
Okay, for breaking, yeah, and okay, the for breaking model ice, but what's the limiting value of alpha? Какое предельное значение?
Ну, 0.04.
0.04. And if we go to next slide.
Isopaper paper?
Next. Yeah, no, yeah, over here. So that, okay, it's always shown by red.
Okay.
Okay, now I understand.
Is this on the isopaper paper or?
Is it on in ISOP paper? ISOP paper, that these slides, these figures, они в статье вашей опубликованы, вы изопик?
Это все опубликовано.
Okay, so I like a copy.
So can you send copies to me and the media, at least that we distribute?
I don't have access to isopaper.
But
We measure just the deflections that is under the submarine, or upper the submarine, or under the loads. That's what does it mean that the range of the way.
yeah, how you measure?
How you measure?
Lambda M, how you calculate? Как вы lambda M?
Профиль.
Profile.
Okay.
Look at the profile.
Для нагрузки сверху тоже 0.04. Это надо.
This
So
can,
the hash is the depth of the water or is the depth? What's
H
Is the-
okay, distance.
submarine then? Okay.
Yeah,
And
distance between. Yeah, that is the sorry, what's that? This is HM.
Глубина воды.
That is the water depth
Up to the
because they use the double bottom, right? So they can make it shallow. Actually, it's very shallow.
Yeah, but I think it's like 1 meter later on.
Yeah, and that is the.
Below
Is
the-
it from ice to the center
Yes,
line?
yeah.
До центральной линии. Или
Yes,
to center line?
So this is showing the influence of this H model.
And if the, water depth is 35 centimeters and length of the model here,
Масштаб 120 получается 40 метров.
that is 40.
Около 40 метров.
The length of the model, I mean, длина вот самой модели какая здесь.
Длина, ну, это метр.
1 meter. 1 meter length and 35 centimeters in the model. So actually it's kind of that steps here.
I think later he has some graph with bigger H, capital H, like 1 meter. Can you go for the next one, sorry?
Because actually it's, could you show next one? Next slide. Следующий слайд.
Maybe next one?
Сейчас.
35 or 04.
More.
Следующий слайд.
Это выступ. Это
Ah,
выступ.
that is about the step.
Okay.
The step on the bottom.
Oh, step.
Step on the bottom. It's interesting. They submitted paper to journal on that. That is similar, quite similar to what John Gow presented. It's a ship moving over the step, finite step. And that is the same, almost the same, but for ice and submarine. Very similar. By the way, very similar.
So the steps it's a step and then just constant.
Finite length of step. Конечная длина ступеньки. Покажите ее какая. Yeah.
Okay, it's fine.
Finite. So the same. It's the same in presentation by John Gow, but in his presentation it was
And the
very
sum-
long, quite long.
And the summary goes above.
Yeah, the
0.16
bath.
or
So,
something.
yeah, so it enters the shallow
Shallow
water
water.
and then leave it.
Nice.
And then when it leaves, it sends the
Well,
wave.
it changed the dispersion relation when it
Yeah,
changed the
yeah,
water.
yeah. But also there is the
It's
finite
finite, yeah.
finite length is important due to some reasons. I don't understand everything, but yeah, it was a research on mini tsunami in Norwegian fjords when a ship goes over the step on the bottom by John
Yeah.
Gow. I'm
This-
talking about, yeah.
Zero going down basically.
Yeah. The ship was such, and that step was such in one of the fjords that the mini tsunami were generated each time when that
Yeah,
ship
because it's exactly the critical speed for
critical
water.
speed, everything. Yeah, very special. Yeah.
Okay.
So that is, they also can be kind of used. I mean, topography can be used on the bottom to break ice.
Сейчас будем делать и уступы.
So they will work on other topographies.
Okay.
Michael, some questions.
Just a request, can you play the first video of the experiment?
Первое
I just
видео,
want
поэтому
to
еще.
maybe ask a question related to this.
Oh, wow.
The question related to this is, when this starts to break up, where's the model in the water in relation to the damage?
Когда начинает разрушаться, где находится подводное тело, его же не видно, где находится по отношению к месту разрушения.
Did you measure this? Yeah. Is it ahead of the damage or following the damage from?
Ага.
Just below.
Just at the middle. So it's a break at the middle of the body, right? Just over the body.
The break is at the middle.
Где ломается лед? За телом или перед телом?
It breaks there at the top.
Здесь.
А.
Это брейк за центром.
Здесь уже
Sure. And the submarine, so the model
So the
follows
breaking.
this breakage. It's net because it's generating waves, I guess, as it passes through.
So the under. Just above.
So it's supplying waves to the surface, but following the breakage. from-
In experiment what Akizawa, he obtained a slight delay of the
Yeah, slight
depression.
delay,
So he was moving stuff on ice and he saw the depression
yeah,
I think behind.
Slightly.
slightly behind.
So it's the load moving, but the biggest depression is
Delay.
just behind.
Yeah.
So that's why this seems to be in the middle, but usually the depression is just behind the pressure. Okay, ice cube is smaller. Yeah.
Okay.
So
Shifting to the tail.
he's doing something else. So you have a thing moving on ice, and then you obtain the depression is not exactly under, but a little bit behind.
Вот здесь не ломается. То есть первый перегиб, он только дает зарождение, она может залечиться. То есть она, сказала, закроется, она не сломает лед. А вот внизу идет раскрытие трещины.
There is also this part and that part. Here the crack starts on the upper side of the plate,
Okay.
and here on the lower side. So here it's open.
I mean,
Open
you're not,
by this.
you're not doing breaking because you're
Yeah, so there
moving
is,
on dice.
yeah, so there is also that difference at which side of the ice plate the crack, I mean tension, which side is tensioned. So this is why it's it breaks his experience. It's a tough. So that is the experience. So we had not many presentations on experience because the program is mathematics of ice phenomena, but the experiments are very good and we needed them for validation of our models and for understanding what's happening. So the cooperation with the experimentalists like Vitaliy should be beneficial. So some papers published, and he recently submitted another paper about the motion about the step. So they're coming. So for his name in the publication. Any more questions? Yeah.
One small question. Is it important, maybe, or interesting to add some currents or waves also, like mechanically generated waves, to see the effect?
Internal waves, you mean?
No, not internal waves. Yeah,
Internal
under
is
the
interesting as
it's
well.
not internal. It's technically just another source.
Another one, yeah.
But not to break dice. So actually it's more.
Если добавить течение и волны.
Да.
Dice actually.
Это в планах.
It is a future plan.
In future.
We
So
can discuss
it's
this.
to install wave maker.
Yeah, but they have to be smaller not to break dice probably because you want to make ice smaller.
Yeah, what he showed me was like that is the ice.
So you still want to see the submarine breaking dice, or you want to see the wave maker breaking dice?
Yeah.
Yes.
The-
Make it somehow not to break down.
Yeah, exactly.
Like
So
this.
just vibrate a little. Okay. Oh yeah, this is the stuff.
Mhm.
Да.
Kind of that. Okay.
Вот еще
In the ice.
течение.
But I say you want to break the ice to the submarine, not the wave maker.
Еще что делать?
This is part of the story. It should be like.
But wavemaker, I guess, is just interesting experiment. But if you add a flow inside, it will change significantly with wavelength. Yeah,
Yeah.
and it is interesting to see the.
Yeah, but the changing adding the current is
Okay.
kind of the same as changing the velocity of the model.
Okay, that's interesting. That's
Roughly. Because
Well-
he launching the model at different speeds.
But on the river, this is more
No, but the
realistic.
idea is that the flow is supposed to be, of course, it will be a profile, but it is like it has a profile. It's everywhere.
It's
everywhere, it's
yeah,
not
I
a
understand. It's not the same. No.
So this is closer to reality in the river.
Okay.
There's a lot of different
Ah.
opportunities to adjust the experiment.
They did like this, but for with elastic,
Elastic plate.
not plate. It's a membrane. Membrane.
Okay.
Tension. Yeah, so that is the no need for ice. It can be done even in, okay, not even in, but in your university, in Tel Aviv University. Just elastic plate, yeah, elastic membrane on the top of the
We
tank.
just we mean like stretching.
Stretching, yeah, stretch membrane. And the membrane is also kind of model of ice.
And also,
Then there is a current, and also it could be if something pulsating, then it can be with waves, and the submarine also can be launched.
Вот мы добавляли
А.
прикольные эксперименты с подводной лодкой на
Okay. So they did it. Вы уже сделали, да?
Да.
They did it with current and submarine, but not for ice,
Okay.
for
Ah.
elastic
Elastic.
membrane.
And for
The
internal.
elastic membrane is made of resin. Is it resin? And the thickness,
2,
3 millimeters. 2-3 millimeters. Just the stretched piece of resin.
And another small question: is there any importance of standing waves in this type? Like laterally, probably.
Yeah.
Стоящие волны, какой-то эффект.
Пока.
So,
Там
Это
нет
подъем
волны,
давления.
то есть там получается... ну мы делали вообще по периметру. Вообще просто.
So standing on the y direction.
could be in cross.
But which direction?
Could be across the channel, not along the channel.
Вращали лодку, да, и смотрели, что будет.
Ага.
Есть угол атаки.
But have you an opportunity to measure them? Standing waves. I'm pretty sure that they are there. Definitely.
We have these
But
questions.
the
because
question
we
is:
have
is it
more
important
waves.
or it's negligible?
So actually the kind of characteristic of the tank.
Yeah.
So the eigenfrequency of the tank.
Yeah.
Yeah.
I said eigenfrequency of the собственные частоты бассейна самого. Они важны или?
Ну, а там нет. То есть какие? Датчик, конечно, что-то фиксирует. Вот. Там ошибка эксперимента еще тоже 15-20%.
So they didn't observe. But on the other hand, we had presentation from Pasheva. She's here. It's about the something moving along the channel, but on the ice. It was presentation in October, beginning of October, and she studied the effect of width of the channel on, in particular, on critical velocity. And that effect is strong. So she is applying her analysis to the tank in laboratory, Vitaliy laboratory these days, because it's 3 meters of the width of the tank is not wide enough. So the walls could be important. On the other hand, the ice is kind of that, it's viscoelastic, so the main thing just dying at the distance from the disturbance. So
Like evanescent mode.
yeah, they just dying. Yeah. Oh, no, due to dumping, it's just the
Because of
decays
that.
with distance from the source, right? And then if that dumping, that so-called viscous dumping in ice is strong, then any other boundaries, they are not, I mean boundaries side on the side could be not very important. So everything kind of localized. And what's in this figure is localized. So it's even not waves,
Yeah.
but kind of that local effect. Right. But it depends. It depends because the viscous dumping. I do not believe that viscous dumping is scaled in this experiment. I mean, viscous dumping in reality and viscous dumping in experiments, they could be very different. And so that is another issue to investigate. Говорю, что затухание у вас, затухание-то не моделируется. То есть какое оно затухание в реальности?
Мы фиксируем в момент только вот как раз нам интересен момент появления трещины. Все остальное график записал, а все остальное это уже нам.
By the way, to the same question, so
Yeah.
interrupting, I saw clearly that you have reflected waves. And I guess it depends on the phase. There can be also effect of reflected waves.
Which video?
Summarized. I guess the last one.
Could you show the second video?
Видео?
It's about reflected waves. Because I didn't see them.
It will not affect much if they take only small space, experimental space.
Мы фиксируем,
Вот-
вот они
вот с
трещины
другой
не
стороны
доходят.
идет.
То есть
Ага,
сейчас
ага.
в этот момент зафиксировали и все.
После
Отражение,
этого
Закончился, да.
а отражение оно уже идет потом, то есть график-то записал, И все, дальше вы
No, the question is that, okay, here the ice is already broken, but probably in the case if you make a add thickness to the ice layer, probably the reflected wave will affect the effect of the breaking.
Break. Yeah, yeah.
Why not?
Yeah, yeah, yeah.
Thing is
So
that
в других условиях, то есть без, если он уже длинный был, скажем, не разрушился, а если с учетом пришли уже отраженные волны, то они сложились и разрушили.
Это не фиксируем.
Нет.
Просто именно момент прохождения нагрузки вот фиксируем. и всё.
Там же юридически.
То есть вот он видно, да? Очень хорошо.
Юридически можно.
What is the object now? Is,
Нет, it's over here.
Вот здесь.
so this is the object, this is the,
Wait. Oh, okay. So it's behind.
it's behind, so this is the flexural waves in front, basically. I'm seeing the first one, for example. Okay.
Oh, yeah. Thank you very much, and thank you for question discussion. And yeah, we close this seminar. Thank you.